Okay, we are on day 5 of Unit 5, and I love this one. Okay, we're gonna like connect all the graphs and get it all together and have a lot of fun here. Okay, so when we are connecting and trying to get this graph and make the graph through all of calculus as well as pre-calculus as well as algebra 1 and algebra 2, it's just all gonna come together. So we wanna usually find all of these fun things. Okay, so I'm going to look at this graph and I'm going to go ahead. The first thing I'm going to do is see, can I factor it? What can I do with this? So is this graph factorable here? Okay, so let's see. 4 and -2, is there anything that will give that to me? Okay, so what are my zeros here? Let's go see. Do I have any zeros, x-intercepts? It's not factorable, so let's go ahead and do well, we could look at the graph or we could do the quadratic equation, either one. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. Oh, and I see that that inside is going to be negative. So there are no x-intercepts here. Okay? What about y-intercepts? Let's see if we can think through that, because this side's never going to be have an x-intercept. So let's see, y-intercepts. And now I'm going to plug in. That'd be 4. Plug in 0 over -2. Okay, I got out -2 when I plugged in y to be 0. Okay, or sorry, I don't know why I just did that. X to be 0, you flip-flop them. Okay. So y is going to be -2. So I know that I have 0, -2 for my y-intercept. Well, that's what we know so far when I go graph it. Okay. So what about the domain? Let's get a little bit more before I do that. Let's go ahead and get my first and second derivative knocked out. Go see if you can find your first and your second derivatives. And pause me, and then I'm going to write what I have. I'm cheating. See if you get the same thing. And unpause me, so you better do this work on your own. Make sure you're good. Okay? All right, so let's see. Here is my first derivative. So when I look at my first derivative, I want to find all the critical values. So I'm going to say, where is that equal to 0 or undefined? So I can see that's at 0 and at 4 from the numerator and then at 2 from the denominator. So I'm going to go ahead and set this guy up, put it in order, and look at f prime and see what happens. So plug it in, see what you get out. I got out positive, -3, negative. Again, remember this is always positive on the bottom, so it shouldn't be too bad. So now I know what f is doing. Increasing, decreasing, decreasing, increasing. So from here, I should be able to talk about where I'm increasing. And where I'm decreasing. Okay. I can talk about where I have a relative max. And I want to go plug that back into my original 0, 0, 4. Well, look at that. This is actually a relative max. We've already plugged that guy in. And then I have a relative min. And go plug 4 back in. And see if you get 6. Oh, I know another point over here is at 4, 6. And I know that's a relative min. down somehow. Okay. What else did I know? I know I have a vertical asymptote. I have this VA here at x equals 2 because that didn't factor. So I can put that in. And yeah, I can go ahead and put my domain with that. So my domain is from negative infinity to just that 2 can't work, and then 2 to infinity. So I know everything else is going to be going on. I can talk about my points of inflection. So let's go back over here. So where does f double prime go, positive to negative or negative to positive? Well, I really only have that 2 that I'm going to be looking at. Because that's my only 0 or DNE on f double prime. So plug those in and see what happens for f. I got negative to positive. So we know we are concave down, concave up. So from negative infinity to 2 and concave up from 2 to infinity, and we have this point of inflection. Actually, we don't have a point of inflection because that's a VA. So no points of inflection. Okay. So, I mean, all of this can just kind of help us get this all together of what we're trying to find. We could absolutely plot some other points, but I mean, this is enough to kind of give us what is going to be going on, okay, with this graph. We could also, oh, we did the vertical asymptotes. Let's do horizontal asymptotes. So the limit as we go to infinity, the limit as we go to negative infinity. So as I go to infinity, I go to infinity. And as I go to negative infinity, that's positive over negative, that would go to negative infinity, which I see. So I have no horizontal asymptotes, but I can see what the limits are going to go out to. So all of this stuff that we have learned can help put everything together. It's just so fun. It's just so beautiful. Okay. So let's just interpret graphs and see how we do with some of these. So here it says, let f of x be a function. So this is f. And I always I put on here, is that f prime, f double prime? I'm always going to label it nice and big, which must be true. The graph of f is increasing on the intervals from -3 to 0. Well, that is not true. Oh, you know what? I gotta read. It's the derivative of f. Here I just yelled and said, you want to label it really big. And then what do? What's up? Okay, no, it is the derivative of f. Were you guys yelling at me? This is what, okay. So, increasing from -3 to 0. Well, that would mean that f prime is positive. That's good. And then 2 to 5, f prime is positive there. Okay, so that is true. The instantaneous rate of change at x equals 0 is 0. Well, what is f prime of 0? It is 0. That is true. All right. The graph of f of x is concave up on the interval 2 to 5. So from 2 to 5, this one is decreasing, which means that we should be concave down. So that is false. Remember, concave up is where f prime is increasing. So this is never concave up. We are constantly decreasing. So this would be C. Okay, here, f prime of x is given, which must be true. See if you can answer this one, and then I'll talk you through it. So pause me and then unpause. All right, so f of x is decreasing. So this is where f is decreasing up here, positive, negative, and it's asking at x equals 3. Okay, so f of x has to be increasing because f prime was positive, so I can get rid of all of the decreasing. And f prime is decreasing there, which tells me that f is concave down there, so I would pick C. Okay, try number 3. Here is f prime. Which of the following statements is true? Okay, so a lot of people try to think, oh, it's not differentiable. So that would mean that f double prime of 3 wouldn't exist, okay? So it's f double prime would be in D and E. But since the derivative existed there, then f had to have been continuous or I wouldn't have gotten a derivative. It would have been like an open hole or something, which that wasn't the case. So since I have a defined point, the derivative existed, meaning it had to have been continuous. Okay, f is increasing from 3 to 7. Well, that's not true because we are in the negative zone. F has a local max at 5, so I went negative to positive, so that would be a local min, which is D. Okay, and F is constant 0 to 3. No, F prime is, but F prime, since this is negative, we would be decreasing at a constant rate, but it is not constant. All right. So I want you to try these next ones and pause me when you do, and then I'm going to give you the answers. So 4 is D. The 6 is D. And 7 is C. So go ahead, see how you do. And we have one more day left in this unit.